Hi everyone, welcome to Mr. B's Learning Channel. In this video, I am going to explain what is differentiation. Differentiation is a method of finding the gradient of a curve. What is the gradient of a curve? At this stage, you know only the gradient of a straight line, right? And how do you calculate that? Change in y by change in x, you know that. And that gradient is same everywhere on a straight line. But when it comes to a curve, each point on a curve has its own gradient. We can use differentiation to find that gradient. And that gradient is equal to the gradient of a tangent at that point. Let me visualize what I said just now. See, I'm drawing a curve. It's a parabola, right? The graph which you are very much familiar with. I'm plotting a point. See, I'm plotting a point. In fact, this curve contains infinite number of points. I'm just plotting one point. And the gradient of this curve at this point is same as gradient of the tangent. Let me draw a tangent. What is tangent? Tangent is a straight line. Touch one point on a curve, see? And the gradient of a curve at this point, let me call this point A. So gradient of a curve at A is same as gradient of the tangent. Okay, so we got a very important relation. That is very important. That is a gradient of a curve is same as gradient of tangent at a specific point. Here, what is that point? A. At A. This is very important. Gradient of a curve is same as gradient of tangent. And we can find this gradient of a curve using differentiation. Now I am going to prove the formula for the gradient at a point, gradient of a curve at a point, or sometimes we call it derivative from first principle. Draw a curve function. See, I have drawn a curve function that is y is equal to f of x. It's a general function. You know that this is parabola. And I'm going to plot 2 points. Point A here, point A, and point B here. The x value of A is x itself, and x value of B is x plus h. That is h unit away from x. That is the distance between these 2 points is what? Is h, right? Okay. Then corresponding y value of A is what? When you go to the function, you know that is going to be f of x, because I'm substituting x here. So f of x. Then y value of B is f of x plus h. So we know that the x value and y value of A and B. What is the x value and y value of A? That is x, f of x. Clear? Then the coordinates of B is what? X plus h. Then f of x plus h. That is the y value, right? Okay. Now what I'm going to do, I'm going to draw a line passing through A and B. See, I managed to draw a line through the point A and B. The name of this line is a secant line, isn't it? It's a secant. Secant is a line passes through 2 points on a curve, not like a tangent. What is tangent? Line touch only 1 point on a curve. So this line is a secant line. Now I'm going to find the average gradient. I think you know that average gradient. What is average gradient? The average gradient between 2 points on a curve is the gradient of a straight line joining the 2 points. So average gradient of Average gradient between these 2 points is same as the gradient of the line passes through these 2 points, point A and B. So I'm going to find the average gradient. So how do you find change in y by change in x? I know the coordinates of A and coordinates of B. So I'm looking for what is average gradient. Average gradient. So let me write it here. Average gradient is equal to between the 2 points A and B. So change in y, that is f of x plus h minus f of x, change in y of these 2 points, divided by change in x, that is x plus h minus x. See, I can simplify the denominator, f of x plus h minus f of x divided by this x and x is gone, so it's going minus x cancel, so you will get h, only h. So we got it, average gradient. I think you know that how do we find average gradient, and I got it, that is f of x plus h minus f of x divided by h. Now I want to find the gradient of this curve at A, the important one, the gradient of this curve at A. For that, I have to make the secant to tangent at A. It is possible only if the value of h moves closer to 0. We call it applying a limit h tends to 0. If you want to know more about a limit, please watch my video about limit. What happens when h moves close to 0? That is, when this h becomes 0, which means x plus h will move to x, and f of x plus h will move to f of x, which means the point B will go down and going to coincide with the point A. Then the given secant become tangent. That is going to be like, see, now you can see that secant become a tangent. Therefore, the gradient of secant going to be the gradient of tangent. All this possible only if h moves to 0. The value of h move close to 0. Therefore, the gradient of a curve at A, therefore, gradient of the curve at A is, we get it how? Apply limit. H tends to 0, f of x plus h minus f of x divided by h. See, we got it, gradient of the curve at A. This is same as f dash x. This thing, see here, we gradient of a curve. This method is known as, the beginning of this video I told you that the gradient of a curve, how do you find? This method is known as differentiation. So this one in short we can write f dash x or f prime x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. This is how we prove the formula for the first principle. Now I will show you one example how to differentiate using first principle, that is using this formula. Okay, I will show you. Question is, f of x is given is x square. You have to differentiate x square using first principle. So look at the formula. F of x is there, then f of x plus h you have to find out. See, f of x is given. How do you get f of x plus h? What you have to do, wherever you see x, replace and write x plus h with a bracket. That is x plus h all square. Now open this bracket. You can use the FOIL method or direct method. That is, if we go with the FOIL method, x plus h times x plus h. Then when you simplify, you will get x square plus 2xh plus h square. So we have f of x that is given in the question. Using that, replace x with the x plus h, you will get f of x plus h. Now we can substitute in the formula. This formula is given, so you have to substitute there. So it's going to be f dash x is equal to limit h tends to 0. In the place of f of x plus h, you have to write this one. That is x square plus 2xh plus h square minus, see in the formula minus is there, then f of x you have to write x square divided by h. Now simplify. You cannot apply limit straight. What happen if you apply limit here? This denominator going to be 0, it is undefined. So before that you have to simplify and make sure that denominator h must not be there. So how do you simplify? I will show you that one. Limit h tends to 0. Numerator, we can see that x square and minus x square is going to be cancelled. So what will be there? 2xh plus h square. See, after the cancelling, in the numerator, whatever is there, always h is common. So we can see that here also h and here also h. You can take h outside. So it's going to be f dash x is equal to limit. See, so far I did not apply limit, so I have to write limit h tends to 0. Numerator, I am taking h outside. So what you get? 2x plus h, because from the first term h goes out, the second term also one h goes out. So what will be there inside the bracket? 2x plus h divided by h. Now we can cancel both numerator and denominator. We can see h there, cancel it. So you will get what? Limit h tends to 0, 2x plus h. Now it is free. We can, there is no denominator, there will not be any undefined condition. So we can, we are very safe to apply what? Limit. So it's going to be 2x plus h becomes 0. H is going to be 0. So the final answer is 2x. Is it clear? So this is how we are differentiating using first principle. I hope you enjoy this video. You can see more questions related to this in my next video. Thank you.